Welcome back. In this video we are going to solve some logarithmic equations. So here I've got a log base 6 on one side and a log base 6 on the other. Those logarithms having the same base and being set equal to each other means that the arguments are actually equal to each other. So x minus 9 is equal to 15. A trick that comes in handy sometimes is to use a base 6 and treat these as exponents, and these will cancel. Now, it's not really necessary here, but it's a nice trick to have in our bag for some certain situations. So then we're going to add 9 to both sides, and we're going to get x equals 24. Now here I can't just drop the logarithms even though they're the same base and there's an equal sign, because I have two logarithms on one side. Before I can cancel out logarithms, I need to condense these. Okay, so there's a subtraction here. That means we are going to divide the exponents. So it's log base 3 of x over x plus 6 equals log base 3 of 3. Okay, now we can put a base 3 on both sides and cancel these, and we get x over 6 equals 3. I'm going to save a little bit of space here, and I'm going to just take this x plus 6 and multiply it over here in this step. So I've got x equals 3 times x plus 6, which I can distribute. So I've got x equals 3x plus 18. Now I'm going to subtract 3x from both sides. X minus 3x is negative 2x, and that equals 18. And then I'm going to divide by negative 2, and 18 divided by negative 2 is negative 9. Once again, I've got two logarithms on this side, so before I can cancel out any logs, I need to condense. Now these are being added, so that means I'm going to multiply the arguments. Log base 2 of x times x minus 1 equals log base 2 of 6. Now, this base 2 will cancel out the logarithms. And for my next line, I'm going to go ahead and distribute this, and I'll have x squared minus x equals 6. I'm going to move this 6 over to the other side here. I'll subtract it, and I'll get x squared minus x minus 6 equals 0. To solve this, I need two numbers that multiply to make negative 6 and add up to negative 1. So I'm factoring. Numbers that multiply to negative 6 and add to negative 1 are negative 3 and 2. So I've got x minus 3 and x plus 2 equals 0. Now my solutions then are going to be what makes this equal to 0, and that would be a 3. And what makes this equal to 0, and that would be a negative 2. So those are my two values of x. Now if I plug these in, so if I plug a 3 in, I get an argument of 3 and 3 minus 1, and both of those are positive arguments, so that's okay. If I plug in a negative 2, I get arguments of negative 2 and negative 3, and I can't have a positive base and raised to a power to get a negative argument, so that solution will not work. So x equals 3 is the only valid solution. Next, I'm going to rewrite this in log form. So I've got log base 3 of an argument of 8 equals an exponent of x plus 2. In order to solve this, I can do the change of base formula. That's log 8 divided by log 3, log of the argument divided by log of the base, and now it's in common log. I can save myself a line by subtracting. Now I can move this over here and have minus 2 equals x. So I can evaluate this with my calculator now by doing log 8 divided by log 3 and subtracting 2, and I get negative 1.07, negative 0.1072. Negative 0.1072. And last, I've got another similar one here. So I've got log with base 2, argument 16, and exponent 3x plus 2. So I'm going to do the change of base formula. So that's log of the argument divided by log of the base. And I'll go ahead and subtract that 2 now. So minus 2 equals 3. So log 16 divided by log 2 is 4. And that makes sense because 2 to the 4th power makes 16. And then minus 2 is 2. So we get 2 equals 3, and that should be 3x. And then we're going to divide both sides by 3, so we get x equals 2/3.